Hello. Okay, so yeah, now we are going to be looking at how to differentiate what are known as implicit functions. You see, so what exactly are implicit functions? So an implicit function is a function which is of the form f of xy. You see, so examples of implicit functions are functions like these ones: x squared y plus 3y cubed minus 4 sine x is equals to 0, or 4y ln y minus 7 x squared y is equals to 7x cubed. So all these that we have here are different examples of what we call implicit functions. You see, so what we want to learn now is, if you are given a function that is implicit like that one, how can you find the first derivative? You see, so one thing that characterizes most implicit function is that it is always very hard to make either x or y the subject. So you can't isolate the y from x, they're always intact together like that. So the question is, let's say now you're interested in finding what dy dx is, given an implicit function. How can you go about that? So to learn how to find the derivative from an implicit function, we are going to look at the following examples. So an example that one may encounter may be something like this. So you might be given maybe x cubed y squared minus 4x to minus 7 plus 3y5 is equal to 0. Then they say find dy dx. So how can you find dy dx in that case then? You see. So to deal with implicit differentiation, this is how we proceed. So every time when you're given an implicit function and they say differentiate it, you always differentiate term by term. So which means you start by differentiating that whole term, go to that one, go to that one, go to that one, up until you have finished dealing with all of them. So which means now, how are we going to proceed? So first thing, I'm going to differentiate the first term. But if I look at the first term already, I see it's a product of two functions, both one being an x, the other one being a y raised to 2, like that. So which means I'm going to apply the product rule. So the differentiation rules of x and the differentiation rules of y are just the same. But you will see that there will be differences in those instances where actually you are differentiating the y variable. You see that? So now, since I'm dealing with this product that I have here, and the first thing that I'm going to do is I'll do the usual thing. I differentiate the first one, keeping the second one stationary. So when I differentiate the first one, keeping the second stationary, I get 3x squared and y squared is stationary. Then next, I swap their roles. So now I keep x cubed stationary while I differentiate y squared. But when I differentiate y squared, I get 2y. So which means I'll get 2x cubed y. Now, the fact that at this instant you were differentiating a y, not an x, your answer when you're done, you multiply it with dy dx. So that's the rule of implicit differentiation. Every time when you differentiate a y variable, you multiply the final thing by dy dx. Then here you differentiate this, you get plus 28, then x to minus 8, and then that is differentiate, you get 15 y4. But again, here we're differentiating a y variable, so you multiply by dy dx, and then differentiate right hand side, you get 0. So this implies what? Now I can group my like terms. So I collect everything with what I need, and then I get this plus 15y4 dy dx. Then all the other term, I throw them the other side. So I will have negative 3x squared y squared minus 28 x to minus 8. So now I can make my dy dx the subject, where I just get minus 3 x squared y squared minus 28 x to minus 8 over 2x cubed plus 15y4. So just as I've been saying, these my solutions are not the most simplified solution, but I'm just all about demonstrating the procedure. You can now take the answers and further simplify them to get the most simplified answer as possible. You see, but this is the whole art behind finding the derivatives of implicit functions. So let's look at another different example again. So another example that we can look at can be something like this. Given ln of x squared plus 2y squared plus 3x cubed minus 4 sine y is equals to 7ex, find dy dx. So how can we deal with this now? You see. So to deal with this is how we proceed. So now we have that guy there. So we want to differentiate a natural log. And we know that the first thing is we differentiate inside. So when we differentiate inside, there are two things. First, we differentiate x squared, that will give you 2x. Then you differentiate 2y squared, that will give you 4y. But the fact that you differentiated a y variable, you multiply by dy dx. Then we know that since you are differentiating a natural log, the answer is always the derivative of the argument over the argument itself. So this is over this. Then plus, we differentiate 3x cubed, which will give us 9x squared. And then we differentiate sine y. So when we differentiate sine y, what do we get? So we know that when you differentiate sine y, you get cos, so you get minus 4 cos y. Since you differentiate a y variable, this also multiplied by dy dx is equals to differentiate the other side, you just get 7e to x, like that. See, so that's what we have. Then now we want to make dy dx the subject. So obviously I can cross multiply with this guy here. So when I cross multiply with this guy, I get 2x plus 4y dy dx, then plus 9x squared multiplying x squared plus 2y squared, then minus x squared plus 2y squared cos, so is 4 that, then cos y dy dx is equal to 7x squared plus 2y squared e to x, like that. So now you can now collect all your terms that you have dy dx together, and then you can simplify. So if you do that, then what you're going to see is that finally you will have your dy dx being, so at the right hand side you'll have 7x squared plus 2y squared e to x, and then this term will join, so we'll have minus 9x squared x squared plus 2y squared, then minus 2x. Then all this is going to be divided by 4y minus 4x squared plus 2y squared plus y, like that. So this is how you deal with implicit differentiation. You see, so every time when you're dealing with implicit differentiation, this is how you go about it. Okay, so another example, because there are some implicit functions that you can never tell that they're actually implicit functions. So let's look at such like that. Like you can be given the function y, which is x to the power x, and then they say find dy dx. So this is also another example of an implicit function. And in order to see it is that when you look, there is no rule in math that can tell you how to differentiate a function by a function. So which means you have to dissolve that. And the only way you can dissolve that is to introduce log both sides. And then we can see that you have ln of y is equals to x, ln of x. Now this becomes an implicit function. So now you can differentiate. So differentiate ln of y, we know that you get 1 over y. But since you're differentiating a y variable, you get dy dx. And then right hand side, you have a product. So this product, first I differentiate x while it's keeping ln x constant. So when I differentiate x, I get 1. So my final is just ln x. Then plus, I now keep x and differentiate ln x. But when I differentiate ln x, I just get 1 over x. So this p simply becomes ln of x plus 1. Then I can now make dy the subject. So what is dy dx? So dy dx is equals to y times ln x plus 1. But y, according to definition, is x to the power x. So which means finally we just have x to the power x ln of x plus 1. Like that. So yeah, this is how you get to differentiate implicit functions. So every time when you're asked to differentiate implicit function, that's how you go about it. So yeah, let's end it here today. See you next time.